the nuclear reactions that we've been talking about, we were starting with naturally occurring radioactive isotopes. But we have discovered that because these release such a huge amount of energy, it may be beneficial for us if we can actually trigger these nuclear reactions. And we have found that we can trigger nuclear reactions in two different ways. One is by fission and the other is by fusion. And so we're going to spend a couple of days talking about these two different types of chemical reactions. The first one is fission. And fission is when you take a large particle and you bombard it with a high energy particle. Usually we're going to use neutrons. And then we're going to cause that big nucleus to be split into several smaller nuclei. So as an example, if I start with 235 uranium, and we said before that that has a atomic number of 92, and if I bombard that with a neutron, so I take a neutron and I shoot it into the nucleus to hit this, when that happens, this nucleus will split apart into two smaller nuclei. And so what I will end up with is 91, a krypton 91, and this has a mass of 36. I will also end up with a barium atom like this, and I will end up with 3 more neutrons. So if you look at this, you can see that just like before, all this is going to add up before. So 235 plus 1 is going to give me 236. So on this side, if I add 91 plus 142 plus 3 of the ones that are up here, because this means 3 neutrons, just like the 3 that we put in chemical reactions before when we were balancing them. If I do that, that also is going to add up to 236 on the right-hand side. I have 92 on the left-hand side, and 36 plus 56 will give me 92. So just like before, it all adds up. But how can I look at this and tell that it's a fission reaction? Well, first of all, I've bombarded it with neutrons. So that's the first key. I've bombarded it with some kind of particle. And then what it looks like on the end is I now have 2 smaller nuclei than I had when I started with. Now, why would we want to do that? Why would we want to cause this type of reaction to happen? Well, as I've alluded to before, nuclear reactions release a very, very large amount of energy. And so these reactions are used in power plants to produce power, and they're also used in nuclear weapons, unfortunately. So these reactions that are released, especially in a reaction like this one, if this nucleus bombards this and splits it into these, and I've released 3 neutrons, now I've got 3 neutrons flying around, and they're going to go back and they're going to hit more uranium atoms that are in the sample and cause this reaction to happen 3 more times. And then every time that happens, I get 3 more neutrons that are produced. And so it's going to make 3 more reactions, which if that's already happened 3 times, now I'm up to 9. And so every time that reaction happens and more neutrons are produced, it's going to trigger more and more reactions to take place. And that's what's called a chain reaction. Whenever the neutrons that are produced turn around and then trigger more reactions. And so this is where we get into the concept of critical mass. Now, critical mass means that I have to have a certain amount of this material present, or the chances that those neutrons are going to run into it isn't great enough, and so a reaction may not occur if I do not have enough of this isotope here to cause those other reactions. So the critical mass is just the smallest amount of material, of this material, that I have to have in order to sustain that chemical reaction, in order to keep it going. If I have what's called a subcritical mass, if you're familiar with a subway, which goes underground, or a submarine, which goes under the water, A subcritical mass would be under the amount of mass that I need to sustain the reaction. So even if I have one reaction that takes place, and maybe I'm going to produce those 3 neutrons, if I don't have enough of this here, the reaction's not going to keep going just because I don't have enough of this to make the reaction keep going. On the other hand, if you have what's called a supercritical mass, that means that you have way more than you need to keep the reaction going, and this is when reactions go out of control. And so with this is the type of mass that they're going to be using when people are going to be planning nuclear weapons, because they intend for the reaction to go out of control and they intend for it to be very, very destructive. And so if you use just slightly over a critical mass, then you can control the reaction, and that's what they do in a nuclear power plant. They want just a little bit more than what it's going to take to keep the reaction going, and so they use just a slight bit more than the critical mass because they don't want it to lead to an explosion. They're trying to harness that power for good to produce more energy so people can power their homes with electricity. That extra heat that is produced is harnessed by an electrical generator, and then it is used to make electricity for people. On the other hand, though, if you go with a supercritical mass, that's when things are going to get out of control and you're going to have explosions like you're going to have with a nuclear weapon. Now, the one thing that is true about fission reactions, and when you're trying to use them to produce power, or if you're using nuclear reactions, and you guys have probably all heard of Chernobyl, the byproducts are also radioactive, and you have to be extremely cautious as you're disposing of that waste so that you don't put other people in danger. Okay, so that is fission, and the next time we're together, we'll talk about the other process that we can use to trigger nuclear reactions.